Hey guys, and welcome to this new class in aircraft systems and avionics. Now we will be discussing the system description of the hydraulic system. Right, so the operation of the hydraulic system is relatively simple to understand. By looking at this image over here, what we can see is that basically what we will have is a reservoir which is full of this fluid, okay? Then we will have a pump which will work as a generator in order to allow for the fluid to move, okay? It will actively move the fluid. This is the idea of the pump. Then what we will have is actually acting cylinder. This cylinder can be a cylinder or not. We basically have an actuator. This actuator will be moving some of the mechanical parts of the aircraft, such as the flaps or the landing gear, for instance. And I forgot to mention that what we have also is a selector valve over here, which will mainly indicate whether the fluid moves in this direction or it either moves on the other direction, okay? So again, what we have in general terms is a pressurizing fluid, okay, which is that pressure, that fluid which is an output of the pump. Then what we have is a return fluid in order to close the circuit, okay, with going back to the reservoir. And the main idea is that the pump moves the fluid. We have the valve that might have, it can have two positions. It can be described as up and down, okay, depending on which of the direction, the direction of the fluid that we have, we happen to decide. Then what we have is the actuator that acts on some mechanical element, and finally the reservoir, which acts as tank storing fluid, right? So hydraulic fluid reservoirs are required by most aircraft systems in order to provide a ready source of fluid for the hydraulic pumps, and also to contain, a varying volume of fluid. This variance, of fluid, results from differential actuator volume, dependent upon whether the actuator is extended or retracted. Now, the main idea here is that if I go back, we might have different amounts of volume, okay, on one side and the other of the actuator, due to the fact that usually we will have, a connector which is only on one side, okay, meaning that we will notice a bit of difference on the volume, right? So the reservoir size is optimized so that only the amount of fluid needed for proper function is carried, okay? In many installations, bleed air will be used in order to pressurize the reservoir, to help prevent hydraulic pump cavitation, right, or any instability due to low pressure. Okay, so in addition to that, we also have filters, for instance, which, as you can imagine, what we do is eliminate any contaminated particles, contaminated fluid inside of the hydraulic system, okay. And basically, hydraulic fluid cleanliness is essential to proper system function, okay. Inline filters are incorporated into the hydraulic system in order to remove any contaminants from the fluid. The idea here is that we simply have like a concentric cylindrical filter, okay, such as these ones. And what you see is we have an inlet, which is on the outside of the cylinder, okay, and then it moves, throughout a radial cylinder, which is a filter. It moves to the inside, okay, and then it just goes out, coming from the inlet to the outlet. This is the main idea of the filter. However, in the case of having a contaminated, liquid, okay, fluid, what will happen is that this fluid will end up, moving towards this direction. And if this happens, okay, because of additional particles, then usually due to magnets or using several techniques, we will actually be able to have this piece moving over here, okay. In fact, it's moving the other way. So basically what will happen is that we will get a notificator, okay, some kind of button on the outside popping out, indicating, right, that the system, that the hydraulic system has some contaminants on it. Then it is the question of maintenance to make sure that all of this actually works and the hydraulic system has no contaminants on it, okay. This is actually a crucial part of the hydraulic system. You have to make sure in all cases that the filters are operating normally. Right, so this is the idea of the valve. Control valves, okay. Hydraulic motors and actuators have an associated control valve, which is positioned in response to a manual or automated system selection, okay. Such as moving the flap lever, for instance. So basically, we have a manual or automatic way to control this, okay. And the main idea of a hydraulic system, of the valve, as you can imagine, is just this is I'm not sure the name of this kind of system, but basically what you will have as a valve is some kind of piece which is moving in some way or another and providing one direction or other to the fluid, okay? As you can see on the red line over here, the fluid is moving on this direction towards this position number 1 over here, but instead, okay, in the first case, but instead on the second case it's going to the other direction. And because we have this interior tube over here, we're actually able to provide also the to make sure that from number 2 it can go outside like this, but also from number 1 it can go through the tube, through this inside tube, okay, to the outside also. So basically, again, what you need to provide is a means to make sure that you can change the direction considering an input, okay, considering the position of this flap, for instance. I think there's nothing more to add here, just the basic notion, okay, of this is a control valve, meaning that we can actually control both sides, right? However, we have, plenty of valves, types of valves. There's so many types of valves depending on the type of operation that we need to use, okay? Maybe instead of having 2 tubes, okay, going to one direction and the other direction and kind of balancing this piston over here, what we have is only one, and, we could have on another side, we can simply have a spring, for instance. So it really depends on the type of the system, okay? But this is the most generic case. Right, and finally what we get is the hydraulic pumps, okay? So pumps are frequently mounted on the engine accessory gearbox. It might depend. And the way that we actually actuate these hydraulic pumps can be, by many means again. So maybe electric, both AC and DC motors are utilized to power hydraulic pumps, usually with 3-phase AC motors being the most common, okay? We also have pneumatic, which would, be using the bleed air powered motors, which is also utilized on some aircraft to drive hydraulic pumps. And, there's several more types, but the main idea here is that we basically have an outside element which we have to control, okay, which we have to move by using electric or pressurized or pneumatic systems. That depends, but the main idea here is that we actually need to move that, and once we start moving that, we start moving this this blue rotating element over here, okay, what we have is that the fluid will start moving from one side to the other at a certain pressure. Okay, so this is what we are generating by using the hydraulic pump. Okay, so yep, this would be a bit of the schematic of what the hydraulic system looks like. This is for all hydraulic systems. In the case of the aircraft, you can see it in several items such as the landing gear and the flaps. Maybe they are the most common, but also in the case of ailerons and the control surfaces on the tail. Okay. And this is a bit of the schematic again, or in the case in the aircraft. So as we've seen, this would be the actuator, okay, having a control valve, as we mentioned before, allowing for the fluid to move in the 2 directions, right? And here we have the example of an actuator acting on the landing gear and retracting the landing gear, okay? So again, because of, by moving these elements over here, what we actually are capable of producing a mechanical work on the landing gear, okay, making sure the piston, by moving the piston, we can make sure that we retract, or I'm not sure what the word is for the contrary, but the idea is either retract or get the landing gear out, okay? So this is what you will be capable of doing by using the hydraulic system. Okay, so now we can go to the next class.